So very good morning to all. Myself Anand, I'm working as assistant professor in the Department of Mechatronics Engineering past 10 years. So I'm handling the BEE Basics Electrical Electronics Engineering subject for first year mechatronics students. In Unit 1, we are going to discuss about the topic of Kirchhoff's law. That is comes under the Unit 1 topic. So we start from recap of previous sessions. So in previous session we are going to discuss about DC circuits, conductor, resistor, energy storage device, and finally crick. So in that, what is DC circuit? DC circuit is nothing but it's a combination of node, branch, loops, resistance, inductor, capacitance, and voltage source only for direct current. So in that, conductor is nothing but it allows the current flows from one circuit to another circuit for left to right or energy source to load. Example, copper, aluminum are the major conductors, and function is nothing but the path for current. So it's the only conductor used to transmit the current from one direction to another direction. And then coming to the resistance, what is resistor is nothing but a device which is opposed the current flow of electrons in a circuit, oppose the current flow. So unit of resistor is nothing but ohms. Function is nothing but the controls current and voltage in a circuits. So based on resistance value, the flow of current will be opposed. Examples are LED lighting and then voltage dividers. So coming to the energy storage, what is energy storage? So we have two types of energy storage. One is current, and one other is voltage. So inductor is store the energy in magnetic field. That is, it is you normally store the current energy, and unit is Henry. And functions and uses oppose these sudden current changes, filters, timing motors, and etc. Likewise, the capacitor is also storage device, that is for voltage storage device. And finally, crick. What is crick? Crick is nothing but the conductor. See, a conductor, resistance, inductance, and capacitance. So conductor is for current flow easily, resistance for resist the current, inductor for store the current value in the form of magnetic field, and capacitor is nothing but store the voltage value in the form of charge. So on coming to the topics for discussion, so today we are going to discuss about the topic of fundamentals and histories and Kirchhoff voltage law, Kirchhoff current law, that is KVL, KCL, and application of circuit analysis, real world examples, and advanced concepts. So move on to the laws, that is Kirchhoff's law. Kirchhoff is the inventor of these two laws, that is VL, KVL, KCL, in 1845. So goods of Kirchhoff is the real name for Kirchhoff. Introduced to electrical circuit, basic component, that is resistance, voltage source, and current. So based on Kirchhoff law, uh, conversions of charges and energy derived. So foundation for analyzing complex DC circuits beyond Ohm's law. So let's discuss about the Kirchhoff's law. So we have two types of law in Kirchhoff. One is Kirchhoff current law and Kirchhoff voltage law. So um, what is KVL? What is KCL? We start from KCL. KCL is nothing but Kirchhoff current law. So sum of incoming current in a circuit is equal to sum of outgoing current. For example, just you take this circuit as a example. Here I3, I2, I1 are incoming current. So I4, I5, I6 are outgoing current. So uh, I3 plus I2 plus I1 equal to I4 plus I5 plus I6. So both incoming and outgoing current are. So coming to the application in a circuit analysis. So why KVL and KCL laws important? What is the application of a circuit analysis? So major objective of the circuit analysis and KVL KCL law is to determine the current and voltage resistance value in a closed DC circuits. The main application is electronic design. So based on design and development of electronic circuit, we can identify the exact current value, exact voltage difference between two sources, that is V1, V2, like that, and power system mesh nodal analysis. What is the limitations? Assumes lumped elements not for high frequency or non-linear circuits and AC circuits. This all the equations, derivations, and analysis methods laws only for DC circuits, not for AC circuits. Advanced is superpositions theorem integrations, software simulations. Some of the software simulations based on this KVL KCL law. Best example is Spice software, and empathetic example is designing a home lighting systems. So use KCL to ensure current splits correctly for each bulbs or each bulbs and loads, and Kirchhoff voltage law to determine the balance voltage in a closed circuits.